Hi, I'm Pat from VMOD 3D Library. Today, we'll learn about applying VMOD 3D Library's textures in Cinema 4D Redshift renderer. Let's take a look at the final render. You can achieve a photorealistic look like this by applying VMOD's textures in Redshift renderer along with creating basic nodes and adjusting parameters. Let's get started. Here's today's fabric. You can get this item with free credits if you sign up for VMOD 3D Library now. Let's download it and check out what kind of textures are included. Here are the downloaded textures. In addition to the 7 PBR maps, you can also see the mask maps. But we'll be using 5 PBR maps today, and we're going to learn about mask maps in another video, so please stay tuned. In this tutorial, we will be utilizing the base, normal, displacement, roughness, and ambient occlusion map among the 7 available PBR maps, excluding the metallic and alpha map. For texturing, I'll use the project file that includes Studio Scene. You can download this project file from VMOD 3D Library, and it is set up with the lighting of an HDRI light with normal contrast and a 3-point light. Here are the render settings. The number of max samples for progressive passes may appear low, but it is actually sufficient, as we will enable denoise to reduce noise. Create Redshift standard material and drag and drop it onto object cloth. I'll enable the RS rendering view to do the texturing while monitoring the rendering process. Then, to edit the texture using the node graph, click on the RS standard material and select the Edit Shader Graph to open the Shader Graph window. To have both windows visible and accessible simultaneously, we'll utilize Dock to merge the two windows together and continue. Let's begin the texturing process by simply dragging and dropping the downloaded texture maps into the shader graph. Now, let's start rendering in Redshift render view and connect the texture maps one by one. First, drag the base color map to connect the RS standard material and select the base color from Base Properties Base. Do you see how it's applied in the render view? Next, connect the roughness map to the RS standard material and select REFL roughness from Base Properties Reflection. When connecting the normal map, you should create a separate bump map node unlike the base map and roughness map. Once the bump map node is created, connect the normal map texture to it and select Texture Input. Change the input map type in the bump map node setting from height field to tangent space normal to ensure the normal map is applied correctly. Then, connect the output of the bump map to the RS standard material and select Bump Input in the Geometry section. When the normal map texture is loaded, the color space is set to auto, which may result in an incorrect representation of the normal map in the render view. Click on the normal map texture and change the color space from auto to raw in FileIO to ensure an accurate representation of the normal map. To connect the displacement map, create a displacement node, link the displacement map texture to it and select Texture, Text Map. The output of the displacement node should be connected to the final output node rather than the RS standard material to apply it as a displacement. Once the connection is complete, you will be able to observe the displacement applied to the cloth object in the render view. Next, before applying the ambient occlusion map, let's slightly scale down the texture since it looks too large. Create a constant node. In the constant node, change the data type from real to vector. Initially, the vector value is set to 0, 0, 0. Change it to 1, 1, 1 and connect it to all of the imported textures. Then, select Scale under General, UV, and Remap. Now you can adjust the scale of all texture maps by changing the vector value of the constant node. The order of the vector values represents X, Y, and Z in that order. To adjust the texture scale, I'll modify only the X and Y values. I think this looks nice. While it looks great enough, I'll try fine-tuning the parameters of each texture to make it more attractive. If you want to adjust the displacement intensity, click on the displacement node and adjust the scale. I'll change it like this. Next, I'll adjust the normal map intensity. You can adjust the normal map intensity by modifying the height scale of the bump map node. I'll increase the value to make it a little rougher. After setting the value to approximately 2, the fabric texture becomes more pronounced and prominent. The roughness map looks good enough without any further modifications, so I will leave it as it is. Now, let's apply the Ambient Occlusion Map. There are several ways to apply an Ambient Occlusion Map in Redshift, but let's take a look at an easy way that I often use. Connect the Ambient Occlusion Map texture to the RS standard material and select Base Color Weight. You can see it gets pretty dark. I'll create a ramp node and adjust it to keep the color of the base map and add more details from the Ambient Occlusion Map. Create a ramp node and connect the Ambient Occlusion Map texture to the ramp node as an input. You can now select the ramp node and adjust the intensity of the AO with the gradient value of the ramp to achieve your desired color. We have successfully applied a texture map and node to add intricate details to our fabric, and adjusted the scale to our preference using a vector value on a constant node. It looks great and realistic enough, but I'll add some additional details in the RS standard material to bring out the sheen and fuzziness of the fabric. If you select the Redshift standard material, you can find sheen. Let's explore what happens when you use sheen. I'm going to put 1 to sheen weight value and use an intense color for sheen color. I'll go with magenta. Do you see the reflection of magenta light on the fabric? Let's adjust the roughness here. If you increase the roughness value, you can see that more areas of the object reflect light. As you can see, sheen allows you to control the color that is reflected from an object, designate the area that is reflected, and use it to make the fabric look more realistic. Let's change the sheen color to match the fabric and adjust the sheen roughness. I think it looks great now. This is how we use texture map images to represent a fabric in Cinema 4D with Redshift Render. Today's project file including the object and lighting can be downloaded from the VMOD 3D library tutorial page. If you have questions, please leave comments below. Our team will be more than happy to answer. We're going to make more videos about how to use digital fabrics in various 3D software programs, so stay tuned. If you enjoyed this video, don't forget to hit the like button and subscribe our channel. See you next time.